I'm glad you could join us today. We've got about 73 people on the call right now, which is absolutely amazing. I can see some of you, but all of you guys can see me and my awesome haircut. Times are strange right now, and while it's unfortunate, I believe we have a unique opportunity to help everyone. You know, most of us are in the business of designing and conditioning spaces and buildings. I'm guessing 1 year ago, our jobs were a little bit different than they are right now. And while safety and indoor air quality has always been a concern, now it's arguably the biggest priority that we have. Here today, we have the leaders in the industry to discuss this. But before we get into the experts that will educate us on this subject, I'd like to touch a little bit on our local ASHRAE community, excuse me. ASHRAE actually did bring us together today, so I'll keep it quick. So I'm Patrick Krause. I'm the president for the 2020-2021 ASHRAE year. I've been involved in our local chapter for about 8 years. We're the biggest chapter in the country. I was membership promotion chair for a few years, and then secretary, treasurer, president-elect, or vice president. Now I'm president. You know, I'm happy to be serving our chapter during these unique and a little bit different times. Used to seeing all you guys kind of in person versus over the internet. So things are a little bit different than, you know, what I'm kind of used to. I was also in charge of the ASHRAE golf outing for 5 years, but unfortunately this year we won't have the golf outing in September. So you're gonna have to spend those 6.5 hours drinking somewhere else. David Lippy is my vice president, AKA president-elect, and basically my right-hand guy. He was heavily involved in CTTC before jumping on the board of governors. I'm ecstatic to have him, you know, next to me during this year. Chris Krebs is our incoming treasurer. I'm confident Chris will be able to tackle all these up-and-coming tasks. He was imperative in YEA in making it the success that it certainly is now, and I'm really glad to have him on board. Danielle Posalia, sure I butchered that last name, Danielle, sorry. I even asked her how to pronounce it, and I think I did it wrong. She's our new incoming secretary. Something interesting about Danielle is she actually authored a children's book about engineering, which is it's really interesting and insightful, so I urge you all to check it out. So the other voting members on our board are Laura Mitchell, Hanadi Slama, Mike Moxon, and Fiona Martin, who was on here just earlier. And then speaking of Fiona, you know, I'd like to thank her for her previous term as the president. You know, her leadership and commitment while busy with her brand new baby was very inspiring and insightful and impressive. So thank you to Fiona. So next, if anybody wants to get involved in our community, feel free to reach out to me or anybody else on the board. You can make an impact and we'd love to have you. So check out www.illinoisashrae.org for all of our contact information. So Young Engineer, or YEA, Young Engineers in ASHRAE, and WIA, or Women in ASHRAE, are some of our more popular subcommittees with, you know, just a ton of people. So the more the merrier on these things. It's a networking opportunity to meet a bunch of people. I mean, I've met good friends, respected colleagues, and impressive individuals in these groups. So going forward, for the foreseeable future, you know, our CTTC chapter technology transfer committee meetings are going to be virtual. Liz, who's on here, she's, you know, she's in charge of all these things, and so she's taking over this. She's so good, in fact, that she got promoted or nominated for the regional CTTC chair. So we've already got pretty much the content nailed down for the rest of the ASHRAE year. So all this being said, like I said, I'll keep it quick. I want to thank everyone for showing up. I'm sorry I don't get to see all your smiling faces in person, but you're in very good company with this panel. I've got the pleasure of knowing, you know, the majority of the people on this panel. And I can't imagine a better group to speak intelligently about this subject at this time. So that's all I got. Liz, I'm passing it over to you. Thanks to everybody, and I look forward to having a great year.
Thanks so much, Patrick. We are also looking forward to a great year. Thanks again for joining us. I'm Liz Zakel. I am part of the CTTC, which is Chapter Technology Transfer Committee for our chapter. And then, as Patrick mentioned, part of the regional vice chair. Just a couple of housekeeping things today. I do have a poll to start us off in just a second. And then we will have a Q&A session at the end of our panel. So please use the question and answer feature in Zoom for questions. And I think that's it for right now, and we'll just get it started. So thank you again for joining us today. We do have a really great panel. I will introduce them very briefly, and then we'll do the polling questions. They'll tell you a little bit more about themselves as we progress to the question and answer stage. We have Matt Dumich, principal at Smith Group, Dave Eldridge from Grumman Butkus, a project manager there. We've got Keith Hamelman, a principal at Canon Design. We've got Sagar Patel, a studio leader at ESD. At least, and Sagar is also our sustainability chair, which is new this year for our chapter. And all of these guys have been dealing with COVID recommendations. A few of them have been on task forces, so they'll tell you a little bit more about that in a bit. I will now hopefully attempt to get the polling going. This should be quick. I think there's just 3 questions. You can go ahead and vote for them. And hopefully you can all see them coming across on my screen as we wait. So basically, what is your role? We just want to kind of know who our audience is, how familiar you are with the COVID-19 recommendations, particularly from ASHRAE as well as the CDC. And are you working with clients for COVID-19 recommendations and design guidance? All right.
We can't see them across the screen.
Oh, interesting.
We only see our smiling faces.
Oh, okay. Let me see if I can share this. Do you see the presentation?
Yes, our smiling.
Okay. Oh, those smiling faces. I thought you meant your in-person smiling faces. I'm sorry about that. All right. Now can you? No, it didn't. All right, well, we will.
We can see you moving your mouse.
Yeah. Told me. It says I'm sharing it, so I don't know why it's not doing that.
Oh, looks like it's seeing fine on the regular participant end. It must be us hosts
okay.
and panelists.
Oh, sorry. Thank you for whoever jumped in with that.
Yeah, everyone's typing away.
Okay, great. So it looks like about half of us are engineers. We have some manufacturers rep and a handful of contractors, owners, and other. And it also seems that most people are pretty familiar with COVID-19 recommendations, kind of what's been happening. And then, oh yes, 82% have been working with clients for recommendations and design guidance. So that is awesome. All right, we will get it started. Keith, I'll let you take it away.
Well, it sounds like everyone is well versed already in COVID and kind of the things that we've been doing from an ASHRAE perspective. So great. This will be a really quick meeting. Maybe we'll all get schooled from you guys. Now, what do we know about viruses? I think this was always the discussion of how easy is it to kill / inactivate. SARS-CoV, CDC has come out with guidance that it's an envelope virus. It's one of the easiest types of viruses to inactivate or kill with the appropriate approach. Again, easiest to kill. Large non-enveloped are difficult to kill, and then small non-enveloped viruses hardest to kill, like rhinovirus and norovirus. So we're dealing with something at least as easy to inactivate. Let's go on to the next slide. So, I always go back to when we started this. Middle of March, all of us went back into our homes to work. ASHRAE started right away and said, we need to put out a position statement. I always go back to this position statement and see how valid it is. One of them was transmission of SARS-CoV-2 through air is sufficiently likely. Changes to building operations, including the operation of HVAC systems, can reduce airborne exposures. This still holds true in the eyes of ASHRAE and the eyes of everyone on this call. Another one is ventilation and filtration provided by HVAC systems can reduce the airborne concentration of SARS-CoV-2 and the risk of transmission through the air. Again, this is another statement that ASHRAE is holding true to and is really coming out as a valid statement. And these are the guiding principles that we always go back to on the epidemic task force. We go back. So we also want to go is know your limitations. This was actually part of a presentation that we did for reopening of schools. Compliance will not mitigate all risks, so you're managing risks. It still is possible to transmit aerosols between spaces through HVAC, so additional consideration is warranted. Many infectious diseases are primarily transmitted through direct person-to-person contact or through large aerosol droplets at a close proximity, approximately 6 feet. That is still holding true. There's always literature that's coming out doing validations. Is that 2 meters a valid one? There's some things that are coming out that might be saying 2 meters might be a little bit more. I do apologize. The dog has been quiet all day except for now. Disinfection of surfaces and sanitizing procedures are still considered a primary means of mitigation. So that, along with smacking a dog. Let's go to the next one. So this is going to be something that comes up in one of the current the new seminars that we're going to have later in the year on relative humidity, 40 to 60%. I know we're going to talk about this a little bit later. Stephanie Taylor, Dr. Taylor, great woman. She's in Boston. She's going to be doing a presentation for us a little bit later, but this is really something that we have been focusing on, and further discussions will be had throughout this presentation. And if we can go on to the next one. Modes of transmission, we keep going back to person-to-person, airborne infection, infectious aerosol, healthcare settings, large groups, stay away from large groups, much less likely than measles, for instance. So just how we get infected with this type of virus and through the modes of transmission. So Dave, I think you're next up on some of this.
Yeah, so this was one of the charts that I liked from CDC and NIOSH had put out the hierarchy of controls. And so you may see this around in some of the ASHRAE materials as well. It kind of helps establish, how are you trying to, avoid the virus. And so we start out at the top with, eliminating a hazard. This applies generally. So you could use this in a laboratory or, other setting when you're talking about, any hazard. When we talk about virus though, you'll notice we get to the middle before we talk about engineering controls. So there's a lot better ways to avoid it through policy and, personal habits than what we can do as HVAC. But still important. And, for all the discussion that we have about masks, so it's important, but it's one of those things that you do last. So try to avoid it first, try to have source control, and then eventually, PPE to protect your person when you're already in the hazard. Go ahead, Liz. And then another concept that came up was a lot of different things are kind of being thrown at us about how we can mitigate exposure to virus. And so the idea that we want to put out there is that research on these topics can kind of start out with what they called here expert advice or case studies, and then gradually more controlled studies. This is borrowed from evidence-based medicine. So if you look up evidence-based medicine pyramid, it'll show a similar thing with a lot of lingo that doesn't exactly apply to HVAC equipment, but the concept is the same, where we're advancing to some experiment that varies in a different way to show the application, what the range of conditions would be that it could see, and tracking against outcomes. And then at the highest level is systemic review. That's going to include a review in the way that you're making sure is the research asking the right question. So not necessarily that we've measured something and after adding equipment it changed, but are we looking at the right thing? Is it consistent among all the research that's available? And can we trace it to outcomes? Go ahead. Let's see, this one was your slide, Keith, if you want to jump back in.
Yeah, I can jump back in. There were, just general concepts that we've been trying to focus on from ASHRAE, and this is really on the school reopening task force. Shutdown of HVAC systems, typically not recommended during the day. Don't turn them off. Recommended temperature range 72 to 76. Again, that 40 to 60% relative humidity. I know we'll talk about that a little later. Increase outside air dilution, more is better. Improve filtration, more is better. That's general order of 13. Permanent apply of air cleaning and disinfecting equipment. Interim filtration and disinfecting equipment, pathogen reduction, air distribution and path, and then also continuous monitoring, making sure that you're actually achieving what you need to be achieving.
So some of the ideas that will get applied now to buildings of all types, I think we can borrow from our healthcare experience, all along, looking at airflow coming from a clean area going to a less clean area, looking at what upgrades can you make, including, definitely the industry is focused on filtration, air purification, ventilation rates, and we're going to hear a lot more about humidification, in the next, the remaining half of the year, and how that can be a benefit. And I think we'll have a lot more focus on airflow patterns. So, filters and air purification, how do they work if the airflow is not in the right place to bring that air to that equipment? So ASHRAE has a really large body of resources on their webpage. If you go to ashrae.org/COVID-19, and it's a little overwhelming. So hopefully this presentation can help distill it down a little bit into some of the key concepts. And then if you need more information, you can go to the website and get the full manual on the topic. One other thing on the next slide to talk about is filtration. Go ahead, Liz. So this was another slide that's been making the rounds with ASHRAE and other materials, showing how the efficiency or effectiveness of a filter changes based on the MERV rating. And it helps clarify, there's definitely some misunderstanding out there that a filter works like a net, and if the particle is smaller than that net opening, then it gets through, which isn't exactly the case. So you can see the capture efficiency of the different filter types, and getting up into the 14, 15, 16 MERV ratings, you've got some good capture efficiencies. And then I included on the left side a little sample of size of particles. So when we talk about the modes of transmission, the droplet size are going to be on the right half of this chart. And then if you had a virus particle, then it would be toward kind of in the middle third on the left side. And so filters can capture these particles of these sizes, it may not be at the high efficiency that you'd like it to be. The other thing to consider is if the virus particle is, is it in the droplets where could be captured, at a different rate compared to, a free floating, virus particle, which would be so much smaller. And then, so we included a couple samples for addressing existing facilities. So these will talk about things to look for in your existing building. The assessment would show what the current capabilities are, and then it would be up to the owner to decide what the risk factors are to decide to do any upgrades or not. We kind of recommended the assessment first, and focus on the filtration, and then on the next slide are the kind of the remaining priorities. Make sure the building is working. Consider upgrades. There's some guidance from LEED and Fitwell's coming out with some additional guidance. There's a well package of materials as well. So there's a wealth of material out there to help people or clients to figure out what to do to their buildings.
Great, thank you guys. That kind of concludes our portion of the actual presentation part. Do any of our panelists have any last minute comments they want to make before we head into the questions? Nope, silence, love it. All right, sorry, 1 second. All right, we are going to take our first, we have some questions to ask the panelists. That'll be our first stage, and then we will have questions and answer questions from the audience in a little while. We're just going to start alphabetically first. Our first question is, if you could tell us a little bit more about who you are and what you do. What was your focus prior to COVID, and what is it now? Let us know any of your ASHRAE involvement too as well, please. Matt, if you want to go ahead and start.
I didn't know if we're doing alphabetical by first name or last name, so thanks. Hello, everyone. My name is Matt Dumich. I'm an architect and a principal at Smith Group. It's nice to see some familiar names on the attendee list here, and I want to give a special thanks to my partner, Nancy Kohout, for encouraging me to participate in this discussion today. So Smith Group is an architecture and engineering firm. Our Chicago office is about 100 people, and I lead our workplace studio. So traditionally, I've done a range of projects from buildings, interior fit outs to large scale mixed use developments. Lately, as commercial office has been completely disrupted, I've been helping clients and really in daily conversation about both return to work and the future of work, and what are the impacts after once we return, and perhaps after we get a vaccine. So whereas I had been previously doing a lot of design of office renovations, now we're doing a lot of strategy and helping clients understand how they might work differently, and the strategy for kind of what the future looks like. And we're learning as we go. This work from home has been quite an experiment, and as we and you can see from all the panelists, we're still in our homes, but we will learn kind of as we start to re-enter the office. Our office has reopened as an option. We are using the concept of non-judgmental flexibility. So if you don't have to go back unless you're comfortable, and it doesn't matter why, whether that's childcare, commuting, or some other reason, you can come back when you're comfortable with that, which I think is a fundamental thing. And to date, only about, I would say, 5% of the office is really back right now. And I've been leading the our return to work task force for our Chicago office in collaboration across our firm. So looking forward to the discussion today. I'll turn it over to, I think, David.
Hi, longtime chapter member. So have worked a lot in the past with energy efficiency, so energy audits, building modeling, sustainability, and that has kind of led into indoor air quality. And so through that, I've been involved with ASHRAE on the TC 9.6 for healthcare. And so part of that has led to working on the epidemic task force on the healthcare section of that group with an alternate care site guidebook that we're partnering with the Corps of Engineers, where they had deployed sites around the country. So we saw several here in town, like the Westlake Hospital, Metro South, and McCormick Place were a couple. So where the Corps of Engineers had a kind of a strict set of requirements, and they wanted to issue some more guidance because they know that given time and budget, that not everything can be done. So they wanted something that was a little more practical to help people choose prioritization. So that's been another big focus. And right now we're just working on, requests from clients about, what is my building capable of doing now, and what are the feasible upgrades that I might consider, in terms of virus. Next.
I believe that is myself. Keith Hamelman. I'm with Canon Design, principal at the firm. I'm actually the firm discipline leader. I do reside in Chicago, but I do work across the country. From an ASHRAE involvement, it seems like it keeps growing the volunteer hours. I am on ASHRAE Education Committee TC 9.7 and also a virtual design and construction TC, where the virtual design and construction TC, we're actually doing our inaugural, effectively a conference in March. So we're giving that a try. I'm on the steering committee for that. But one of the most interesting things is I was asked to be on the epidemic task force subcommittee for reopening of schools, which has put out a series of guidelines and is really evolving throughout the industry. Been giving presentations on that. We gave one in June. We had about 1,100 people attend for ASHRAE. It's really great. From a overall perspective, we're still working from home in the Chicago office for Canon, but our other offices are going back. We're planning on going back sometime in September. And, what was I doing before and what am I doing after? I used to spend a lot of time on a plane, worked predominantly in California, but also in the East Coast plus Chicago. And now I'm living in Chicago, still working in California, and looking at how the world is changing, where maybe it doesn't matter as much where you reside, how you're able to do work across the country and still do it effectively. I think we're on the next. Yep.
That's me. All right. So good evening. My name is Sagar Patel, and I am the Energy Eco Studio Leader over at ESD. Chemical engineer by trade. I've been working in the energy efficiency and sustainability world for I guess the last decade now. Focused on energy modeling, commissioning, retro commissioning, all that stuff that came out in 2008. Prior to the pandemic, our group was kind of focused on trying to save the world. There's a lot of attention on carbon reduction, greenhouse gas reduction, net zero goals, but we were also kind of building up our healthy building services. We had a couple of buildings get certified last year with well certification, fit well certifications. So we released with developing that. Obviously, that's been now full throttle and accelerated with a lot of attention from our clients. And just recently, it's kind of been this balance act of immediate reopening plans, like what do we need to do from a functional testing standpoint, things to identify for our customers. There's a big push for transparency. I think that never really existed before, how to communicate to our tenants that we've been doing things. documenting that information for them. So kind of getting up and running on that end, but then also looking, 6 months out, 9 months out, a year from now, what are things they need to be considering as well. Our group also, kind of early on was focused on building analytics and using that kind of information to help in, provide insights from energy efficiency was really a big thing in O&M and operation maintenance. But obviously now there's a thermal comfort component, there is a functional testing standpoint, and I think this all can be kind of continuous. I think that's one thing I think we need to be really aware of is I think this transparency and constantly providing information that might be one thing that's going to stick around for a while. And so we're kind of helping our customers navigate that as well.
Great, thanks, Sagar. And since a lot of what you just said rolls into our next question, I'll let you start with it. What are clients asking for now to address COVID in existing systems? And if you want to throw in some of your typical recommendations, that would be great.
Yeah, I mean, it's really funny how much filters all of a sudden become really apparent to all our buildings that never really existed before. And economizer sequences, right? I mean, it's really fascinating, the things that we always thought were important, but now that, the owners are driving that and want more information around that. So, I mean, a lot of what we're recommending is you got a baseline. I mean, you got to know where you're at and also functionally test everything, right? Make sure the things you have actually work. And so like kind of a big recommendation to say, hey, just go through a functional testing kind of exercise, use a third-party engineer, knows what they're looking for, and that can document, give you kind of a nice little report just that says, this is what you have. Because a lot of it, I mean, it's really kind of also interesting is, everyone's kind of wants the fancy technologies right away, but as engineers, we know like, we got to hold on. There's a lot of things that lead up to that point. And I think Dave did a great job of kind of actually, showing that, you got to do all these other things before you get to that point and before you start spending it. I think it's also interesting is how much money all of a sudden showed up to do these projects that never existed before. And so I think at least that's kind of our immediate response is kind of based on where you're at, making sure you have the right other policies. There's a lot of other non-HVAC things that have to be in place prior to you start attacking the HVAC. And so then we start kind of going from there. So the recommendations are, everything that ASHRAE is putting out, we don't want to, I guess, from our standpoint, we don't want to go too rogue, right? ASHRAE is putting out a lot of guidelines. So kind of following that. And I think what's been great, I think early on is kind of this overreaction. Here's all the, just run everything 24/7 all the time. So now they've, I think they've released a new thing today where it's like, okay, just do 3 air changes, 2 air changes, or now it's 2 hours, but no, today was 3 air changes.
Oh, 3 air changes. Oh.
Now it's 3 air changes, literally was put out today. So, right. And so we kind of come down. And I think that's one thing from a COVID thing is also we have kind of prep our customers is like, hey, we're going to go really, really far because we don't really know this virus very well. And as we evolve, we're going to evolve our expectations and how we operate the buildings as well.
I'm just going to jump in. I like to jump in. This is meant to be conversational, and hopefully I might answer a couple of these questions along the way that it seems like are coming up. Existing buildings, what are the challenges, and what are some of the recommendations? Challenges that we seem to be running into is deferred maintenance. For years, we've had deferred maintenance in buildings, and that outside air damper that we thought worked didn't work. So some of the things back again, what Sasha was talking about was making sure that you have a baseline, understanding how your building is operating. But then when you get there, get some outside air to the building. Look at your filtration. People ask, why did you choose MERV 13? We can get into that a little bit further, but it's a good discussion on a MERV 13. You can get a 2-inch filter bank. And in schools and other facilities, most of them already have that 2-inch filter bank. So the common sense things. Looking at air change rate per hour, I think one individual here asked a question of, would it be better to run a VAV system in constant volume? And the real answer is making sure, one, you have outside air that you're delivering. There's the Wells-Riley equation. And, the Wells-Riley equation started looking at the probability of infection if you have a spreader in the room. And is a spreader heavily breathing and speaking loud, or are they really quiet and sitting in the room? And how many quanta per hour that individual is putting out. So when you start looking at it, a air changeover rate of around 6 air changes an hour, you start seeing a point of diminishing returns. And that's where a lot of those recommendations is minimum. So when you're looking at a VAB system, if you can at least try running it at the 6 air changes an hour, we're seeing definitely a benefit. especially when you start looking at, for those not aware of the Wells-Riley equation in the charts, you actually start seeing a diminishing point of returns versus going to an air exchange rate of 12 air changes per hour. I know that some individuals on some of the subcommittees are starting to look at calculators in order to do probability of infection based on time within a space. How many hours are you going to be in there? How many minutes are you going to be in there? Hopefully that stuff's going to be produced and sent out by ASHRAE. But it's really based on what is good information, good theory.
Great. Dave or Matt, do you want to go expand on that, as well as like what clients have been asking for you?
I guess I wouldn't say that they've asked this question yet, but one of the advice that comes up after, hey, we want to assess our system is going to be the flow pattern. So if buildings are set up and you're pouring this, say you get the 6 air changes, but the supply and returns are not set up in a good way, you may not be really clearing out the whole room. Is it really mixing well? So you're working with the healthcare facilities, there's a table from CDC that explains if you had a room and it was contaminated, but the source of contamination leaves, how long do you have to either run outside air or a HEPA fan filter unit to reduce the room to 1% remaining contaminant. But there's a footnote to that table, like is the airflow pattern going to really be mixed in this room? So that, if you're not well mixed, then the time is going to be much longer. So all the things we're talking about, I think there's going to be a lot more focus on how is the air supplied and returned or exhausted.
I'll just add a couple things. One, I appreciate Sagar's point about transparency. We are definitely seeing tenants ask their landlords for a lot more information and a lot more, adjustments to their systems. I think it is important to, and by the way, most of our clients aren't back in the office yet. And so there hasn't really been a lot of requests for physical changes to space, at least not yet, because there aren't enough people. If they are back, there's not a high density. And so I do think in these conversations, it's important to kind of sort out the immediate short-term return to work and then the long-term impacts. And I know we'll get there later today, but I just want to encourage all of us to kind of think about it, about these issues in those two ways.
Great, thank you. Some of you covered this, but if any of you didn't get as much info as you wanted on, what are any of the challenges that you're seeing with existing buildings? I think, Keith mentioned some of them, but.
Right off the bat, just make sure, ventilation air, like you just don't have either ASHRAE minimum, right? Or they don't have any kind of economizer sequence built in. I think City of Chicago, obviously we have a lot much, those larger air handling units, which are capable of doing it. But when you start getting suburbs and you have these rooftop units, equal zone units that, just bring in very minimum air, you're going to, that's a challenge to make sure it's just a physical constraint, right? That's going to be something that they have to be able to overcome. The other part is just, the ventilation seems to be the building pressurization, right? Be able to maintain those because, you bring us outside air, can you bring the air out? And so the kind of those balancing. And then the deferred maintenance is just huge. It's just things that you've been kicking the can and now you have all these band-aids around that you need to overcome. And so I think that's definitely, but it's always been a challenge. And I guess we can kind of, I don't want to say exploit it, but right, we can use it to hopefully get these buildings right. That sounds.
The ASHRAE page has a lot of material on what operators can do. And I think that's, really important. Having been on, I do Green Globes assessments. So walking through buildings, I'll find a lot of, filters that aren't being maintained or they've become so loaded that they, get pulled. So there's bypass. Occasionally, find a unit that's makeup air that, you know, isn't running or not running at the right speed. So people need to take some time to go back through their buildings and, you know, start at the basics, you know, just make sure those systems are working the way they're supposed to before you get to the more advanced stages.
You know, it was interesting at the beginning of this whole pandemic when everyone was back in March and April saying, oh my God, what's going to happen? And we actually had clients calling us and they weren't even aware of some of the things that were in their buildings. It was the knowledge transfer over the years where maybe back 10 years ago under the facility director at a hospital, we designed in a pandemic mode that was easy to switch on. That was 3 facility directors ago. And none of that knowledge was there. And I think that's something that we're also doing as a lesson learned through this of how do we continue to keep that knowledge transfer? How do we start getting that information out in the future so that it's there and it's not lost when you have a facility director or a building automation maintenance individual who moves on to a new facility.
And actually another one that, I mean, David brought filtration. There's a lot of MERV 8 filters out there. And that's a really big challenge to be overcome if you wanted to upgrade to a MERV 13. And even just again, just trying to get to that point, right? 13 to 15, I mean, those are a little bit easier, but those MERV 8s, I mean, that's going to be a big challenge for, I think, a lot of these buildings. And then I guess maybe it's because ESD like consults in technology, but like that's also, I think, a big thing for a lot of this work from home mobility. Really, I think is going to be a big focus for buildings, or not even like tenants, right? I mean, I know a couple of companies that just didn't have the physical bandwidth to be able to handle people work from home, and I think that's going to be interesting where there might be a lot more of that kind of structure getting built out, either in a building or like maybe in data centers, things like that, which is going to be kind of interesting.
Yeah, and I want to go back quickly to what David mentioned with the ASHRAE checklist. And, you know, they do have those great monthly checklists for maintenance, and we have been including those in any of our indoor air quality reports and recommendations as easy reminders and something that they should be doing every month, because I've had the same issue where you worry about putting all of these extra things that will take more maintenance, like higher filters and those kinds of things, and you worry like, oh, you're not really changing your filters right now, or your condenser coils are covered in dirt and cottonwood in the middle of the summer, and you're concerned about keeping temperature in your building.
And it's interesting as you say those building readiness checklists. You know, ASHRAE is in the process of just continuously reviewing them. Of course, the dog had to start up again. Continuously updating those items, and you know, we keep on looking at it as how do we do this continuous improvement.
Thanks. So in addition to, so we've talked about filters being one of the more pretty low cost item to recommend to implement. Do you guys have any other lower cost items that you're recommending or seeing implemented on the HVAC side?
A lot of buildings have economizer cycle in this area, and so we want to make sure that that's running the way it's supposed to start with, and then you might consider that you could extend it a little bit. So if maybe you can run part economizer, part mechanical, or in some cases you might be able to change the temperature set points a little bit. So if you said we're going to relax the conditions in the building, you know, can we get a few more hours and run economizer? So that's one kind of low cost, no cost option to look for on the HVAC systems.
I think a lot of buildings also have, as a response to like bioterrorism, they have like a purge sequence that you could now, you got to be cautious with that, right? Because it's a pretty high velocity sequence, but like that's been, at least some buildings don't necessarily have the economizer, but they can go to a purge. And so that's at least been one small recommendation. what's been interesting is some of the buildings that have like floor-to-floor air handling units, right? They have a floor-to-floor also containment. And so we've seen a little bit more attention on that versus like a centralized system. This might get into some stuff later. But at least that's been kind of interesting, is containment becomes a really big hot topic as well.
Yeah, you know what? Something that's low cost is going through and making sure that your maintenance is up to date and understanding where your building engineers and your facility personnel may not have been replacing belts on exhaust fans. We have one client who went through and started finding all these exhaust fans in toilet rooms that, you know, maybe didn't have all the PMs done on them. Making sure that your outside air dampers are actually operational. It may not be that it's fully controlled, and it might just be that you're opening up, but at least you're bringing in outside air. These are lower cost items that will have a direct impact on the health of your building. It's interesting, the Government Accountability Office actually produced a document that it's indicating, I think it was in 60–70% of schools that are not bringing in adequate ventilation. And it's because of maintenance issues and maintenance items. Everyone has always said, oh, we'll steal that money, or we'll defer that for future. I think now we're at the point where we need to start focusing on that maintenance. And that's a really low cost item.
Absolutely. All right. So I think we're gonna switch gears a little bit to what is happening now and go on to looking at some of the future impacts. So our first one is, what are clients' biggest concerns that you're seeing now for their future design? Matt, do you want to start?
Sure, thanks. It's across the board. And frankly, I think if my hope that the future, and we're talking about post-vaccine here, is that we'll be somewhat familiar, but it'll be more flexible, and it will, I think the two takeaways are flexibility and wellness. And we should get into wellness at some point. But I think really what our clients are asking is, will people ever come back? Or will the full squad ever come back? And therefore, on their real estate portfolio, do they need less space? Or how do they plan for this? Because I do believe we've learned that in many cases, remote flexible work can be effective. And I do believe it's here to stay in some way.
Absolutely. David, do you want to go ahead?
I guess, yeah, looking at a lot of buildings that are going through a third-party certification like Green Globes or LEED, there's a more focus on some of the wellness IEQ items. So I guess I can't be specific whether everyone's going to jump to ultra high filters that they're not required to do. I guess it's a little early to say that way. On the healthcare side, there's more concern where where you're in the building has a lot more potential for infected people. So in that case, one of the things people are looking for is the flexibility, so that in the future, if they need to do something like this again, that they have an easier way to get in and out of the mode, instead of setting a bunch of things manually, or in some cases taking out windows to put in fan filter units. Is there a way that the system can provide what they're going to need in the future, but still run in an efficient way for hopefully decades that they don't need to.
I think from a base building standpoint, right, it's doing everything it can, HVAC, cleaning, hygiene, all those things, to get people back in the building, right? Because I mean, right now they're in this weird flux where the whole building's occupied, or unoccupied. So they want to get people back, so they can start charging rent. Let's just be honest, right? They want to start charging rent to get people back in. Tenants are concerned with, okay, is the building doing everything we can to get back in? It's kind of pressing them on that end. And then what do we need to do to make sure our tenants are comfortable in the space? But then also having that map up, that question is, do we need to go back to the office? And that's like that's a really important question that hopefully doesn't get an answer anytime soon, selfishly, right? But like, so that's, I think a real big challenge. But then also I think just being very poignant, like getting people in and out of the building. And so our ESC's office is in Willis Tower, and that is and we did a quick calculation for them. If they were to do a 4-person in through the elevator, it would take 4 hours to get through the building to get everyone in, right? So like that would be a huge detriment, right? So now, right now the building's pretty much empty, and so you can get in pretty easily. But that's like, like the vertical transportation becomes a really big component. Understanding from a base building standpoint, they want to have a pretty strong understanding of how many people are coming back so they can have the proper response. But then the tenants don't really know what the building's been doing to get people in. So like kind of those conversations are really, because I think it looks like everyone's willing to work together, willing to spend the money, make the efforts, but they have to have a good understanding of where does it make sense. And I think David brought the energy component too, is okay, I'm gonna do all these things, but what's the energy implication? And at the same time, going to 2020, there were a lot of greenhouse gas emission reduction goals and carbon reduction goals that haven't come off the table yet. And so, and that's a really big challenge for a lot of these big, large firms, a lot of REITs, to what's the right balance act? And so it's a hefty thing to do between now and the end of the year when these goals have to be met and still try to get people into the building. And then for a lot of large portfolios, you have state to state requirements that vary. And so now imagine that, trying to manage all that across your portfolio standards, and like a customer asks you or what do we need to do? Well, it depends on your state, right? And so those are like a lot of big hurdles as well.
Yeah, I agree with you on the energy side. I think everyone's taken the stance of let's just burn as much energy as possible in order to deal with the pandemic. And there's others that are starting to realize, wait, we can't do that. But on some other things, it also depends on what market you're in. I do see that filtration is going to be enhanced. We used to go back and look at LEED and say, oh, that MERV 13 credit, we're not going to do that. Well, chips and MERV or chips and LEED, you're now doing that. It's going to be pretty standard in schools. You're going to see that standard across offices. What was always interesting, and it's a challenge for schools, for higher education, and also ambulatory care centers. Everyone heard the buzzword negative pressure room, and everyone wanted one. Oh my God, I need a negative pressure room in my building. And I can count on all my fingers, all my toes, how many clients asked me that. And then I said, do you want, what do you want? Do you want an AIR room where it's 100% exhausted, 12 air changes per hour with HEPA filtration on the discharge? And they go, oh, no, I don't want that. I just want a room that's negative. So you kind of get into that. And then you go to yourself, what is the real purpose of why do you need that? So it's so many things are just changing. Just the advent of telehealth and how telehealth is really moving forward. What does that mean for an ambulatory care center? What does that mean for a hospital? We're actually seeing a shift, and some of our clients it's actually going to increase our volume that we're seeing. We may now have more diagnostic requirements versus having as many exam rooms. It's that shift that we don't know. And I think some of us are just taking that path of, all right, let's ride this out. Let's not make overarching statements. I know when everything happened in March, everyone went crazy of, I need to do HEPA filtration of all my exhaust air from these COVID-19 rooms that I'm just dumping outside. And when we're really looking and saying, how do you deal with an AGP, an aerosol generating procedure? And what do you do and minimize the risk, the PPE, the things of that nature? So I know I'm rambling a lot, but it's a very open-ended, intriguing question that we're going to keep asking ourselves now in the next 6 months, a year, what's changing? And it's by market.
Great, thank you. Did anyone else have anything to add about, what your clients are asking for? I know, so much is still in flux that maybe they don't know what they need yet. you know, Matt had mentioned that their clients aren't back in the office yet. And David had mentioned about healthcare. And personally, we've seen things where people don't necessarily want to put in alternate filtration or things immediately on some of like their air handling units that are going in, but they want the space to do that. And they want to make sure they have the infrastructure to do that, but as an alternate, really.
Yeah. You know, maybe I'll just jump in a little bit on this one because we get asked this all the time. All clients, even ourselves as engineers, we've had people asking us, let's do bipolar ionization, let's do UVGI, let's increase our filtration, let's do things of that nature. And our clients are being asked that. And they're asking us as engineers, professional engineers, what is the recommendation? And it's not a one size fits all. And it's also a avenue and a discussion of, well, let's also wait and see. Let's look at your building. Let's see what fits in your building in the short term. And then in the long term, let's start evaluating what are those items that are out there, and understanding what is the effectiveness of the kill rate of UVGI on a first pass. How much wattage do you need to actually make that happen? And what does your velocity look like? What happens with bipolar ionization when you're inactivating the virus? You know, just those items that maybe we're not all the data, all the science is still being worked out. That's us.
Yeah, that's great. And also a great reminder that I believe we brought up earlier too. You know, this is evolving. What we know is always evolving. So, you know, we are going to have to, in the future, look back on things that we did and see what worked, as well as people are actually going to be able to test using the virus at some point, which very few technologies are able to test against right now. Mm-hmm. As well as, you know, things that are happening that may be political or maybe not, like access to tests, like actual COVID tests. So you know, have a better idea of, you know, are things spreading in different ways across the board, and what other things people are doing to mitigate transmission.
Well, and time is telling with the studies that are being done. You know, in March, when everyone went into lockdown mode across the country and partly the world, we weren't able to run those studies. Now we're starting to see things coming out from Australia that they're running studies, and these are not scientifically verified yet. So that's where we always have to go back and look and ask ourselves. But where individuals who are COVID positive are in rooms with children and they test the children in the room and they're not coming out positive. That's just one example. The point of when you're finding active viable virus, you know, what is the level of viable virus does it take before you're actually infected, and how long is your time duration? We don't know those things. So there's just so many studies. I think in the past week, I've been given about 7 different studies, and my head's spinning by each one of them.
Yes. Anybody else with any comments on future design? Nope.
I think I mean, we don't know. I mean, right now we're like pure entropy, right? I mean, if there was ever a definition or an application for it. I think what's really interesting is we have the entire world at one point kind of focused on one mission. And so the research that's coming across the world is really like, we're never going to see this. And the adoption of new technologies, I think, is really intriguing because there are people willing to do it. So now you have this really great lab space to like try out these technologies. Now, I think you brought up a good point, Liz, though, is that, okay, but how do we measure it, right? That's like the biggest laggard in all of this, is measuring the actual virus reduction. Air moves fast in a building, and to then try to capture where was the virus reduction. I mean, that's going to be the biggest challenge. And then truly, I mean, if we're being the pure optimist, there might be a point where this all gets settled out, and then what was all this for, right? Versus, again, the pessimist is, okay, there's never going to be a vaccine. Then this becomes a lot more valuable. And so I think from a future standpoint, I mean, it's challenging, but they also have to, I think another part that's been really, I'm sure everyone's gotten inundated by that one research paper from the CDC in China at the restaurant that it was transmitted, right? And everyone's probably rolling their eyes in this exact moment because we knew where the limitations in that actual research were, right? But that causes that fear or a misunderstanding of what the HVAC, now the HVAC becomes a transmission mode for a virus. So now we have to overcome that part before we can even start entertaining the other part of, okay, here's what a proper response looks like. And so I think that's going to be a big challenge going future is just at the same time the entire world is out there doing a research paper, there's stuff going around everywhere too. And I think that's going to be a big part is like, and coming out as engineers to make sure we're doing the right things and have a good understanding. But also, we're also not hygienists, right? We're not in the medical field. And so we have to kind of rely on these other people to do the research to help us with the research. And so that's it's a tall order for us engineers, I think, coming up to be able to manage all that. But I think, and I know that's probably a really weird futurist kind of mindset. But I think that's going to be a big thing for us is to really stay on top of like all this research and make sure, and, you know, and understand how the technology responses are and making sure like all this, you know, we have this great experiment going on that we can actually get a lot of great information from.
And I think, sorry, go ahead, Gabe.
No, I'm reading some of the questions that are coming through.
I was going to say, Sagar's comments and as well as the groups kind of roll into like what the future of client requests are going to look like. We're probably going to see more people requesting, you know, either commissioning or future commissioning testing that's done for air quality, you know, things like that. Matt, since we haven't pinged you too much specifically for your office work and what you do you anticipate any changes from clients in the future? Or, you know, we're also worried about, especially in Chicago, you know, where most of us build offices and residents, you know, with a shift in that with work from home.
Yeah, again, I'm optimistic that there will be some recognizable normal at some point where I think a lot of these issues will be tempered as we get more comfortable post-vaccine. So I do think, again, and we've talked a bit about this, that wellness is here to stay. Maybe my one design idea is how can you get outside more or maybe get more fresh air? But yeah, will we be, one solution is don't be, limit the time you spend in enclosed spaces, open a window or go outside. That's been one of the nice things about being at home, especially when the weather's been nicer, is have access to an open window.
That's an interesting one. So this has come up a couple of times on existing buildings where a multifamily building has a DOAS system. And so they have an engineered airflow and it's operable. And so they got a lot of questions from the occupants about, I want to open my windows. And so there's a section on the ASHRAE page about that where the windows of the apartments were in close proximity. Opening the windows could cause loss of control of the mechanical pressurization, as well as entrainment between apartments, as opposed to the DOAS air that's, you know, coming in filtered and clean from the top of the building without other you know, sources of contaminant. So that was an interesting side note that said opening your window in some cases might not be the best if it's not meant to be the primary source of your air.
Yeah, it's interesting, Matt, how you're saying clients are going to be asking for more ventilation and how you're enjoying your time outside, being able to be outside. It's how many more buildings are we going to be designing with natural ventilation systems incorporated in? And more importantly, what does that mean to us as US citizens, Americans. We like our buildings to be nice, comfortable, 72 degrees. And if we go at 73 degrees, we start complaining. That's one of the reasons why I always see a struggle in the US with some markets of doing natural ventilation versus Europe. But are you going to start seeing more of our clients demanding that we include natural ventilation? And is it not going to be something that just gets knocked off as a cost item and VE? And are you going to look at fan assist systems and a different tolerance level that we deal with when we're in a building? If it's a little uncomfortable, okay, that's fine, but we're getting better fresh air. It's interesting how even ASHRAE and ASHRAE 170 is starting to study the use of natural ventilation in hospitals. I just said that quietly, but that might be coming out pretty soon if it's already out there. But how can you use that? It's going to be used more in temperate climates. Chicago, we're weird because we aren't temperate. We've got the tropics and we've got Antarctica at the same time, and maybe 2 months, 3 months out of the year where it's beautiful. California, totally different.
I think going future, I think it's going to be tenants. I think at least the customer. I think certifications are going to become more apparent, more pushed again. So you well, fit well, even reset, right? Reset's got a really great kind of position right now. So certifications are going to probably be pushed a little bit more, just because it's kind of that catch-all from a wellness standpoint, and they're pretty vetted and they're science-based. But then we're also seeing a lot of traction just from like a trending standpoint, like active measurement of air quality, room temperature, health, relative humidity, all those things, right? And so I think that's going to be kind of just the idea of can I observe what's going on, and then it keeps bringing up, right? Like, okay, what are the temperature? What are those space requirements that we need to maintain that's comfortable, but not maybe reduces virus transmission, and kind of keeping those in. And then I think once people kind of aware of like, okay, if we were in this range and we are a little more forgiving, there's some good, there's a positive from it sucks, but yeah, from a standpoint of we're maintaining a virus, right? We're not providing a space where they can actually propagate. That might help. And I think just that trending and that kind of visual goes a long way. So I think you're gonna see a little bit more. I don't think there's gonna be a lot of, there could be so many different ways to solve pressurization and like isolation, all those things, but I think there's gonna be more of an awareness just from certifications create that, right? That visual that you are at least holding yourself to a standard, and trending, like now there's obviously some caution, right? Like not every building owner wants to put out everything, but potentially to see like if someone does a report monthly, just says, hey, this is where we've been at. So I think you're gonna see a little bit more attention in that.
We do have some more questions left that we had curated for ourselves, but I think we're gonna jump to some audience questions since we've got just about 20 minutes left. David brought up a good point. One of the questions would make an interesting poll, so I hopefully made that really quick. So I'll ask you guys to let's see. I can launch this poll really fast, and then we'll have the panelists open it, respond to it as well. So if you could only make one improvement across ventilation, filtration, relative humidity, or airflow patterns, what would you choose as having the biggest impact? Oh, we don't really have a front runner as of right now. So the options are increased ventilation rates, increased outside air rates, increased filtration, humidity between 40 and 60%, or airflow patterns. All right, we'll just give you a couple more seconds since 71% of you have voted. All right, so 26% say increased outside air rates, tied with increased filtration. So our panelists, I think you have mentioned I think really most of these, especially the ones that are easier to implement, but if you have a favorite or one that you recommend the most, let us know.
If we go to ASHRAE website, and they've got a couple case studies. So one is that Gongzu restaurant where the super spreader was at a table, and all the people downwind of him from the they had, I believe it was a mini split system. So the evaporators blowing what seems to have been air from him across the next tables. So I think airflow pattern is one that I think needs to be considered more. So if the virus is in droplets and it's touch and it's aerosol, but maybe it's kind of short range aerosol. So we don't have a lot of case study that says it's getting through a return air system and actually infecting someone else in the building. I think the room is got to be one of the big focuses. And so if we're looking at a situation where there's mostly healthy people and a few infected people, I think to protect the people in a room from the potentially infected person in the room would be one that I think we'll look at a lot more. Although that's maybe harder than upgrading filters or some of the other measures.
We're going to start a fight because I disagree. It's going to be, I'm very much about ventilation dilution and reducing those concentrations and kind of like beating up the virus with as much air as we possibly can. And I think it goes in the airflow pattern at the end of the day, because you got to get, what you bring in, you got to bring out. So I think that's a big major one. And I think really challenging like Chicago's market specifically with that is the fact that our coils can't handle all that. And like we just had like in a ridiculously hot summer. And so buildings really couldn't handle doing a full economizer, full flush out right now. And so maybe that's something I'm a big proponent for ventilation. I think it's the easiest thing to do. And then the filter is a secondary, right? It's your first active air cleaning. But like if we can just kind of dilute the concentrations of anything in the air just with fresh air, I think that's definitely the right way to go.
Yeah, I'm kind of cheating a little bit because I got a little calculator that I just looked at, but really it's start with the outside air. Let's make sure you're bringing in fresh outside air. And then look at your ventilation rates. When I say ventilation, it's air turnover rates, how I define it. And making sure that you're delivering that. That's going to really help. And then you start going back down, it's like we're going through the list. The top three things: outside air, air change rate, filtration. You do those and get started on that. That's great before you start applying some additional technologies.
Now, as an architect, I'm completely unqualified to answer this question, but Liz said we could mention the one we like. And I'll just stick with the increased fresh air.
Actually, Keith, I do have one question actually back to Keith. And maybe this goes back to that first slide of the envelope virus or the type of virus we're dealing with. And you had the list. How many of those what's the tendency of the airborne virus? Because I think that's kind of what may play into this is what is an airborne virus typically that envelope type, or is an airborne, can it be any of those? Because I know the rhino, noro, those tend to be on surfaces, right? And so I'm kind of curious if
I think you're looking at the envelope, I think was also an influenza A virus. So it's something that can be done through an AGP. So when you sneeze, when I say AGP, it's aerosol generating procedure, but basically you sneeze, you produce an aerosol. Or when you're going in being intubated and extubated, that was always the concern. Or when they were doing the test, you sneeze. So I think I think I'm answering your question, but that's where we were looking.
I guess what I was ultimately correct. I always thought this virus was kind of it was a weakling, right? Hand sanitizer killed this little virus, right?
Yes,
No,
bleach works well.
Right.
So does washing your hands with soap and water. That is number one, people. Please remember that.
And so like it was always just kind of funny. Like I don't know, I always felt like, okay, then if air can, ultimately if you just kind of bat it around in the space through just moving it around, it would probably kind of degrade. And so I don't know, sorry, a little
Yeah,
off topic there.
no, but I think it gets down to, we just don't, some of these things we just don't know yet. We don't know how long this thing sits in the air before it drops down. What are the technologies? Okay, so if we use a technology that is, you know, attaching itself and allowing it to fall out to the surface, is it still active? And then are you then picking it up from that active surface? I don't know the answer yet. And I don't think the studies have been fully completed because we just haven't, you know, we're 5 months in. I'm looking at my little clock here. The last time I was on a plane was March 12th. So 5 months ago. And we've learned so much, but we know so little. You know, back to what Dave said, does it go through an air handling system? There are studies out there that have actually shown that it does go through an air handling system and bypassed the filtration. Now, that's an unvetted study. We didn't know the condition of everything. There's a lot of holes to do. That's where science is going to take place. We're going to keep going back as engineers and scientists and start looking and asking these questions before we come to the real decision. But again, get back to basics, back to good things. You know, I think this goes back a little bit with what Cigar was saying. You know, just even commissioning, but you're also going to start seeing more regulatory requirements. California is interesting. They have mechanical acceptance forms. So you actually have to, prior to getting your certificate of occupancy, you have to bring in a licensed test and balance or a professional to go in and check that your ventilation system works, your FDD works. All of these things work to meet the energy requirements. I can tell you definitively that this is being pushed in other parts of the country. And it may take Chicago because, you know, Chicago, we tend to be a little slow in how we do things. It might take 3 years before it gets here, but it's going to get here. And it's going to be an impact to us as designers, us as contractors, us as owners of facilities, because it's going to impact how long it takes for us to build things, what it's going to take to actually cost to do this. And it's going to be here. It's not going to be here tomorrow, but it's going to be here probably in 3 years in Chicago.
Can we expand a little bit more on, there's a number of questions about alternate technologies for filtration. Do you guys have any opinions on, or could go into a little bit more about UVC or bipolar ionization? You know, some of those are for, you know, improving effective air changes was part of one of the questions, and in general using them. And have you been recommending one over the other to clients that are looking for something like that?
At least I know from our, so I mean, the two that ASHRAE initially promoted and supported was UVGI and HEPA. And we think, you know, and they have, their technology has been around for a while, used in hospitals, labs, for, you know, the UV we put on cooling coils as just to clean them and kind of disinfect them. So there's definitely merits in that. UV in occupied spaces, I know there's some, ASHRAE's got research to go on both ends, right? They have to go, you know, have a very low laminar flow, less than 6 air changes, or I think it's like 200 feet per minute for that UV to be effective. So like obviously those, so you have to be really cognizant, but also you're putting a source of radiation into a space. And so being very, very aware of like where you're putting it, and really ensuring that it's designed properly and the safeties are in place in those things. HEPA, I mean, we know the HEPA is not just, it's not a drop-in place solution, right? And any building fan system can't handle just putting in a HEPA. And I feel like in the future, you could consider it, but I guess, and I don't, there's not, this is kind of a personal anecdote, but a little more like, we can make the building as clean as we want, but then what? Right? There's a reason office buildings aren't clean rooms. I mean, there's a fan penalty, there's energy penalty, but there's also, I would think, if you make the space too clean, then your body's not fighting anything ever. And so there's some, you know, could be downsides to that and things that we should be considering. And the HEPA is very expensive. It works, but it's very expensive from a maintenance installation. And so that, you know, there's some downsides to that end. But then we've been exploring like bipolar, and I think it's a really cool technology that seems to have a lot of, at least from the research we're reading, I mean, it seems like a viable option It's not terribly expensive. So if you're looking for something to retrofit, it's something you could, consider to add on to the filters, especially if you don't have, if you have a MERV 8 or MERV 13 filter and you want a little bit more of a boost, I think it could work. And I think ASHRAE even has come around a little bit on their position on the bipolar ionization. And then PCOs have gotten a little bit more attention as well, right? The photocatalytic oxidizers. They've been around for a while. I mean, the downside to those obviously are either the ozone production, which I know there's trace amounts and you put detectors in, you can do it's maintained properly. But then the other side of it is the PCOs. If you don't get that full charge, right, then you don't get the full oxidation. Then the byproducts that you get formaldehyde and other like free radicals in space, and that could be bad. And so that's obviously a risky position. And so like obviously everything has pros, cons, but really is important. Like, you have to put things in the best position for them to be successful and make sure they're applied properly. So I think the one that at least UV and HEPA seem to, those are HEPAs are great for localized solutions. I think UV is great for the cooling coil. But then the bipolar ionization, I think, is one that I think is really interesting and can be really compelling. Because there's at least a good research on like the reduced particulate matter. And so if you're looking from an attached virus standpoint, if you're reducing particulate matter, you should be able to, in theory, be reducing any attached virus concentrations.
I'm sure we'll get that research soon that takes it to the next step, so we know, there's case studies advertised on particulate. So it certainly does that under some certain conditions. The industry is going to need it to go a little bit further to show how it's affecting, viral particles, and also the limitations on the room conditions. So is it going to work with airflow set up in a certain way, or if the inlet and outlet are not in the right position, is it still going to work? Is there, concerns? Does it work differently with humidity levels that are changing? What if we take some of those measures? Does it still perform or not perform? So we still have some questions, but definitely worthy of being considered.
Sagar, I think, oh, sorry, go ahead, Keith.
No, I was going to jump in because I always like to jump in.
Yeah.
I think it's an interesting question. Bipolar ionization, we've all discussed. I think there's going to be more studies. I agree with Dave. I think what's interesting is UVC. That's been really pushed, especially upper air UVC. But always people kind of forget. We need to look at the materials that are within the building. We don't want to do harm. We don't want to cause our building materials to deteriorate too easily. Even when you're putting them in duct situations, you want to make sure that you're not putting it in and it will deteriorate your mastic within your ductwork. I'm just talking off the top of my head on this, but those are items. We've had these discussions with clients all the time. I think even with humidity, I know that we're going to have a further discussion with Dr. Stephanie Taylor at a future meeting, but I can tell you as part of being on the epidemic task force on schools, we had a long discussion on humidity. And the folks down in Florida and in areas that were more, they're summertime all the time there, 40 to 60%, no problem. More than that, no problem. I had to do a timeout of the group and say, what about us in our northern climates? Most of our buildings aren't built to be humidified. And most of them are not built to be humidified at a 40 or 50%. And actually, if you look at the extrapolation of the influenza A, it says that you want to be at the 70% range. We know we're not going to get that in the dead of winter. We know that if we even get 40% in our best hospital, in our best building in an envelope, we're going to get frost. We're going to get water. We don't want to destroy our building envelope. It's always funny when I get asked the question of, this teacher wants to put a humidifier in their room. Is it gonna help? I'm like, no, it's really not gonna help because your building's not humidified and you don't have vapor barriers in the room. So just always interesting.
Yes, thank you. So that kind of hit on one of the questions about outside air or about relative humidity, sorry. And then Sagar, one of the questions was, I think regarding how you had brought up like the flush at the end of occupancy, was it the air changes now that ASHRAE just came out with today? But with those air changes, was that 100% outdoor air, or was that just like recirculated as well?
It's the outside air equivalent, right? It's whatever so depending on whatever, they got away from the time component, and they're just saying you need to do 2 or 3 full air changes of outside air of the volume of the building. So yeah, that's kind of, you have to do though. So if they just had min OAs, then obviously it's going to take much longer than versus the 100%. If you can do full econ.
Great, thank you. We're going to go into some more specific questions. Does anybody have any tips for improving or increasing outside air within tenant floors that have limited OA available? Or do you look into improving filtration at that point? I think a lot of tenants run into the problem where they have just a main air handling unit, and you get the amount of OA that you get.
Who wants to jump on this hand grenade?
I guess I would just go back to the idea of the air changes, similar to what we just kind of built off of. Just if you can, if the tenants can, ask them just run longer. I mean, you're looking for that flush out and just keep running. Yeah, I mean, that's definitely a hurdle, but I think if you can keep just moving that air around and changing it out, you're in a better position than not doing it.
Well, and it's always, City of Chicago is always interesting because we've always had the City of Chicago ventilation code that says for an office building, you need 0.6 CFM per square foot. And of that, 33% of that needs to be outside air. So that works out to 0.2 CFM a square foot. Conveniently, in most leases for Class A office buildings, you go at a 1 CFM per square foot is kind of design standard, which works out to the 20% outside air. Where I'm going with this is most of our buildings are delivering a 20% outside air. How does that equate to the ASHRAE 62.1 current versions? I haven't run all the calculations, but again, back to what Sagar was saying, let's look at ways of, one, making sure you're bringing in outside air. I think we've been to many buildings where maybe it's been challenged. Let's also make sure that we're not having demand control ventilation systems installed. So that when an occupant leaves the room, the box goes to 0. Look at where your boxes are set at. Should they be set at temporarily and even always when a building is occupied at a certain level? It's such a difficult question, but you got to start asking those questions.
I have a question that you will not see, panelists, in the list that someone had asked me earlier. I know, we throw you all a curveball. So there's been some, well, I guess I'll just phrase it like this. How viable, if you've heard of this, do you find exhaust air testing to be as a means for detecting infected persons inside the building? If you're capturing measuring contaminants in exhaust air. Yep.
Yeah, so that's not something we can really do.
Yeah.
At that, most of these tests you're going to hear about, they're taking some sort of culture, and then has to go back to the lab and then be developed to find out what's been in the room. So they're not able to do that dynamically in that sort of way. I have actually seen several articles about it going out the water system.
Yep.
Where they're able to take some cultures at the community level and say, where they actually, in some cases, had started doing this testing, detected virus in the effluent, and the outbreak showed up 2 weeks later or a week later when enough people had actually gone in and been tested. But yeah, still not dynamically, in the way that we can look for virus that way.
Yeah, it's interesting on the whole fecal material. and why we've looked at toilet rooms and said, make sure your toilet exhausts are working, back to a simple thing. But you're actually going to start seeing maybe a change in design philosophy. You know, in the past, we used to have gang toilet rooms that had one exhaust, maybe over the ADA stall, and we supplied air. You're actually seeing, and the school committee has come up with an exhaust over each water closet. Are you going to actually get away from that, and you're going to start seeing individual stalls, especially as you're getting into more European style of unisex? It's going to be a change. To answer the other question, I do have a client out in California who, you know, believes not that you're necessarily testing for the virus, but let's test to make sure you have good indoor air quality. And he's going out and buying on Amazon air monitoring systems and going through and going into his buildings and just checking to make sure that you're maintaining good indoor air quality. That's a good step. I don't think you're going to be able to effectively test if there's viable organisms running through an exhaust system in an HVAC. That would be hard. Possible, but hard.
Yeah, just real quick, going back to your indoor air quality monitors and monitoring. Next month's meeting is in conjunction with Big Chai. So we'll go into that a lot more next month about specific indoor air measurements and monitoring continually.
Cool. It's like I'm feeding into the next meetings.
Yeah, wow, how does this work?
I didn't even know that one was coming.
Yeah, I didn't tell you guys about that one.
Mm-hmm.
So we are already past our time limit. Let me know if you guys can take a few more questions, or if you want to all wrap up with one of the last questions that was on our curated list of, you know, how you see the future use of office changes impacting HVAC design, like the office becoming used for something different than everyone going there just to work.
I'm up for taking a couple more questions.
Okay.
And then we can kind of weave in also that one too into our answers maybe.
Awesome. Did anybody see any that they want to get out really quick? Oh, I kind of liked this one. What is recommended for schools that only have partial building automation systems and partial window cooling units and ceiling fans? I'm sure we'll go back to a lot of, you know, increasing the filtration as much as you can at the units, but anything else that you could recommend?
Yeah, that's an intriguing one. Because you're almost looking at building automation systems in part of the building, but you have window shakers. You know, in the city of Chicago, for public schools, up until very recently, you needed to deliver outside air to all of the rooms and have ventilation air. The recommendation would be, if there is the ability to have ventilation air, you bring it in. From a window perspective, if you're with your window shakers during the summertime, and you still have the ability to bring outside air in through your main air handling systems that might still be operational in the building, do that. Again, worst comes to worst, open a window. Outside air is better than just stuffy, no air. Thoughts, anyone else?
Clean more. I mean, it's really clean more. Make sure you have the social distancing, the PPE. I mean, you got to do all those other things. Kind of. That's definitely a limitation.
Mm-hmm. Okay.
One of the typed in questions was CO2, and that's one I meant to mention earlier. One of the low cost measures where 90.1 has been asking us to put in demand control ventilation for conference rooms. Now we want to recommend that maybe that be disabled temporarily, so that when you're sensing CO2 and you're not going to slow the air down necessarily, you might leave that at the design flow rate, while we're under these conditions.
Yeah, I think someone just said I need to bring my dog over. You don't want to meet her. It's interesting because there's also that philosophy, which I don't think has been fully vetted on, do you measure outside air CO2 and have an offset associated with it? Or do you have a fixed number? I learned this lesson kind of the hard way, but it was interesting. You know, when you're in Chicago, we're pretty much always 400 parts per million, unless you're sitting next to a swamp or something. But when you get out on the coasts or in the Caribbean, you may actually have pockets where your outside air has CO2 levels that are approaching 800, 900 parts per million. And yeah, it's understanding that offset. I think you're going to see more and more shift to an offset. But, you know, the idea is bring in more outside air in your building. You don't want to lower that. I think ASHRAE has actually recommended 800 parts per million as a point of setting. That too. Again, please don't quote me on it. A lot of things that run through my head.
Thanks. This one, just kind of throwing it out there. And do you hear customers unrealistically hoping that the HVAC system will protect them on its own or in general?
I'm going to say, I think it depends on who your client is too. Some clients want to be able to have something that they can say, look, I did this. And that's usually where your recommendations are. Whenever I talk with anyone, it's about risk mitigation. Back to the chart that Dave showed earlier on, how do you reduce your risk? How do you decrease the probability of additional infections to the point that you're minimizing it without increasing costs? You know that there's some actuary out there that's calculating out based on the cost and the value of a human life. What is the benefit of, you know, how much should we be spending? I hate to go morbid that way, but you know, it's that way. You know, I think even in our earlier discussions, Matt, I think it was you that was bringing it up. What's going to happen to elevators and ventilation rates associated with elevators, and how much time you're sitting in elevators, and how effect that is kind of an interesting one.
That's a good cue because there's a question about elevators.
Yeah.
Oh, good God.
Yeah. Circling back to the vertical transportation dilemma, could you discuss strategies to safely move many people through a high-rise building in a timely manner? You have any comments on that?
I mean, I know offices right now, and I'd be curious what Sagar says about Willis, super tall, but you know, one is just limiting occupants and in some cases staggering arrival times, which can help. And then the challenge is that they are limiting capacity. In the case of our building, it's two people per elevator. I'm not sure if that's a universal rule or if it depends on the size of the cab. But I also understand, and I'm sure the rest of the panel can advise on some mechanical considerations for the cabs as well.
Yep.
Yeah.
Sorry, my internet totally went out on me there. Oh, it's going to go out again.
Sort of.
Yeah.
I think it's going to be interesting what the elevator manufacturers are going to do. I remember when all this started, one of the recommendations I gave to a large school district in the state was, you know, make sure your elevator exhaust fan and your ventilation fan is running. So always get an elevator, make sure that's working. Look at the number of occupants. Look at how long it takes. And it's going to get down to probability of infection. If someone in there is infected, looking back at the Wells-Riley equation, are you going to actually start seeing little fan filtration units being installed on top of elevator cabs in order to provide HEPA filtration? Are you just going to see an increase in the amount of air change rate? I don't have the answer, but it's going to be an interesting dilemma. And is it going to really be that much different between, you know, what we dealt with influenza and what we're dealing with COVID.
Thanks. We're gonna go right into a couple questions for David. So I think they both work well together. Have you seen more requests to consider displacement ventilation? I think that kind of covers it both. You can respond to any more details of the questions if you want.
Yeah, I think that's a great question, and that's why I answered the poll the way I did. I think, in the case of the restaurant case study, you could see that people to one side of the spreader became infected, and on the other side they didn't. So it was an issue of the airflow coming across all those people, and that even if they had an exhaust fan on that far wall, it would have. I don't know if the result would have been different or not. So I do think this is going to be a big focus. I don't know if we've been asked about it as much. So when we do the hospital spaces, we have a lot more material to go on how we set things up. But I think when we get into the other occupancy types, I think we're going to be pushing more of the lessons that we learn on healthcare projects and from displacement projects that we've done elsewhere. That it's going to provide a better indoor air quality in the occupied zone. So I think so.
Yeah. Yeah, I think that's, Dave, I'm going to also jump in on this because it's a question of displacement ventilation. Are you going to see that? Maybe we're going to see that more and more in the larger spaces, in an individual classroom, understanding just the currents and the particulates. I haven't been able to get someone to run, what happens with small little particulates within the space on a displacement ventilation, because often you're running at a little lower velocity. And you're allowing in displacement ventilation that plume of heat to take care of it. You might actually start seeing that we do a reversal where we might have more up, where we're distributing air up high and we have low returns, similar to how we do operating rooms, and understanding what type of airflow pattern and direction, or I don't know what the answer is going to be, because each one of these is going to have huge space constraints.
Great, thank you. I think that's good for all of our questions from the audience. If you guys want to end with kind of going back to one of our original questions about, how is the use of offices changing, or how offices are used changing, and how is that impacting probably what you will be doing in the future in terms of design for HVAC, or, building offices, or where you hope to be? Like, do you want to still be working from home and see reduced capacity at your own office? Since it's a curveball, I'll just let whoever wants to take it first go.
I see the use of the office changing. It's not going to be the place where there's the focused time. You might be doing that more when you are at home or sitting at the local bread shop. It's going to be more where you're collaborating with others. In my role position, of course they start barking again. In my world, in my role, I work across the country, and I actually am on an airplane often, and I get more done on an airplane or in my hotel room sometimes. So, but I do enjoy and need to be in the office for that collaboration, the meetings.
Matt, do you want to go ahead? I know you had talked about this as well during our initial conversations.
Sure. First of all, flexibility is here to stay, and I think that's a good thing. But definitely the use of the office, as Keith is saying, will change. I believe it will be for culture and collaboration. And I totally agree that it's likely that focus work could be happening elsewhere, whether that's home or somewhere else. I mean, it's all about providing the space where you can do your best work for the task that you're doing. And as a result, I think that the office design will change. Right now, we have a lot of open office spaces, and maybe that's not the only kind of space. Maybe there's a few phone rooms and huddle rooms with video conferencing. But now that there's going to be a more distributed workforce, there'll be different types of spaces, perhaps a lot more phone rooms to take that private phone call or your video conference from the office. And as a result, you know, spaces will be different and the system serving those spaces will be different. But again, I think the flexibility is a really good thing for humans to just kind of de-stress and have an option to, again, like I said, to find the space where you can do your best work. So I think, you know, again, we'll learn a lot from these experiments, and but the net result will be a really positive on people and on office culture.
Agreed. And I don't see anyone going back to being okay with not seeing our faces on conference calls. That, you know, nobody saw my face before. Now you get to see my kitchen and my living room all the time.
Mhm.
Sagar or David?
I guess I don't know if this is ASHRAE exactly, but we've been able to be productive at home, you know, as a company. And so I think looking to the future, there might be some opportunity to continue working from home as long as it's being productive, and maybe we'll have to work on just our scheduling. So when you have those tasks that you need to be in the office for, you can, you know, get those grouped together so you can, you know, maybe do a hybrid approach instead of being, you know, home almost all the time like we are still right now.
Mm-hmm. Absolutely.
I think just building up what Matt said, the flexibility I think is here to stay. I think we proved in. I think there's always high level executives that always say you had to be in the office. That's obviously proven that it's going to work, and they've even like completely changed their kind of lifestyle around it. But I do think like it is going to be task oriented, right? So like Gensler had a really great article they presented to Big Shy last year of like different kind of work. Like an accountant versus marketing versus the architect versus all these different roles have different requirements. And so and they did a big survey, and it was just ultimately like, okay, for the creative and the collaborative people, they need to be in the office space. For the accountant, which is just task oriented, they're okay being work from home. And so that flexibility is gonna be really important from like all aspects, but just kind of varying on the roles. And then if you need to be in there, I am kind of curious, like and maybe because I'm just kind of old school in the sense of like, you know, mentorship, like where does that kind of fall into this? How does that, you know, because I think it's really maybe disadvantage to the younger engineers, architects, or I think this might be more for the professional of, you know, how do they, you know, make sure they don't get left behind by working from home. And because, you know, they're going to work from home if they could. I think I would. And so I think that's going to be flexibility is, I think, the name of the game. So I am kind of curious though how it does change like how we design floor layouts. Like, does the air loop, is that still a viable option, or do you have to be a little bit more discretionary, right? Or how we like distribute the air? I don't know. And also I think, hey, you know, talking to a lot of people from back in the day, you know, there was a big overreaction to 9/11 that the building's going to change, and then really nothing really changed. You have to check in when you go into a building, or there's TSA. And so I think you're going to get the whole gambit. You're going to get the ones that are going to say, we are like Siemens in their position of, you do whatever you want, right? I didn't see that coming, but like them putting that out there, I think is a big, bold move. Whereas I think some other maybe small startups were like, no, we need to be in the office. Like we need to be able to work together and do this because we don't have the money to invest in these technologies. And so you're going to get everything. And so ultimately, I think the answer is going to be nothing may change, right? It's just people evolving and those who are going to stay the same.
Yep. Great. Well, thank you, gentlemen, all so much for joining us today. Your insight and your ASHRAE expertise and general expertise is super appreciated.